Some of the functions that are a little more obscure, I would say, I don't even really know why we have to know too much about secant, cosecant, and cotangent. I don't know why they're all that helpful. But we're going to because they say we have to. And then we'll do some like trig equation sort of stuff, which is going to be very important for some stuff you got to do in calculus. And then at the end of this unit, we do polar coordinates, which I think are really cool. And are using like naval navigation and stuff like that. And they're not, at least the way I used to teach them, they're not very hard. I don't know, I haven't even looked ahead that far to see what AP is going to require of us. But the polar coordinate stuff, I'm not too worried about. Some of this other stuff in the middle is a little tricky. We talked about tangent some already because we said tangent was sine over cosine. We also said if you got coordinates that it can be y over x. And I believe we mentioned that tangent is also the slope of your terminal ray. So we may even want to write that in right here. When it says m right there, it means it's the slope of the terminal ray. So several different ways we can use to find tangent. A little bit of this is going to be some stuff we've already done. A few other things are not. It says here, as we did previously with sine and cosine, we can use our understanding of the tangent function to develop its graph as we look at the slope of the terminal ray as our angle theta increases from 0 to pi over 2. So he has put, like, here we got an angle of 0, so there is nothing, right? Slope of that line would be 0, right? And he wrote m equals 0 right there, but the slope of that line right there would be 0. And then, as our angle gets bigger, what happens to the slope of the line in each one of these pictures? It increases. It gets steeper, right? In fact, this one right here is at pi over 4. What is the slope of the line right here for this one? If that is pi over 4. At pi over 4, what are our coordinates on that unit circle? Root 2 over 2 and root 2 over 2. What do we do to find tangent? Sine over cosine. Sine is your y coordinate divided by your x coordinate. What are you going to get when you do square root of 2 over 2 divided by square root of 2 over 2? 1. All right, because something divided by itself is just going to be 1. So if that's pi over 4, your tangent is 1 because sine and cosine are equal to each other. And then here it just gets steeper and steeper, right? And we could even, as p gets closer and closer, it's going to get steeper and steeper and steeper and steeper until it's eventually going to get to where theta equals pi over 2. Now, what is the slope of that terminal ray? What do we call the slope of a line that is vertical? It is not 1. 1 is the slope of up 1 over 1, so that's like a 45-degree angle. We can't even use a number for it, right? So like as you think about the slope of a line getting steeper, it gets steeper and steeper and steeper and steeper, and the number goes up and up and up and up and up, bigger and bigger, until it's vertical, and then it's so steep that you can't use a number anymore, and we just call it undefined. So the slope of a vertical line is undefined. Think about your coordinates right here. You've got 0, 1 at that point right there. So tangent of theta would be 1 over 0. And can you divide by 0? You cannot. So that would be undefined. So what we're seeing here is at 0, our tangent is 0. And then it's going to get steeper and steeper and steeper and steeper and steeper and steeper until we get to the angle of pi over 2. And at pi over 2, it's undefined. All right? And then we're going to go to the other side. Okay? So if we think about what our slope would look like here, this is just slightly past pi over 2. What's the slope of that line going to be? It's going to be very steep, but is it positive or negative? Negative. So that might be something like -8 or -10, or it's going to be a pretty big number. Then as we go around, we get numbers that are going to be smaller and smaller and smaller and smaller. So let's estimate here. Let's say that maybe our slope is -10 here. What would our slope be? We would know it for sure right here. What would our slope be right here if that's pi? Right, the coordinates right here are -√2 over 2 and √2 over 2. And if I do sine divided by cosine there, I'll get -1, right? This one right here would be somewhere between. Maybe it's -2, maybe it's -3. Just an estimate so we can think about what's happening. What's our slope over here at the last one going to be? It's 0. So this one's somewhere between that. Maybe it's -1/2 or something like that. Probably not, but let's use the squiggly equals because we're just estimating right there. So what we're seeing is at 0, our slope is going to go up, 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 undefined. And then it's going to go a super big negative number, and then it's going to increase back to 0, right? And then the whole thing's going to happen again. From pi to pi over 2, if we sort of think about this, do we have a positive or a negative slope here? It's positive, right? That's increasing. So tangent is the only one that's positive in the third quadrant, right? Your sine and your cosine are both negative, so it makes your tangent positive. So like here, this might be something like 1/3, and this might be 1/2, and that one that's bigger than 1. That might be about 1.5, and this one might be 3. And then what are we going to get back here whenever we have that vertical tangent again, or vertical terminal ray? That's undefined. Yep, undefined. 0 is a horizontal line. Vertical has a slope of undefined. Okay, so this is a key concept that we need to know. Each time the terminal ray is vertical, the slopes are undefined. Okay, they approach positive or negative infinity. When we graph the tangent function, this means that you will see vertical asymptotes. When theta equals pi over 2 and 3 pi over 2, and then each half turn around the circle after that. And so if we were to graph all of those points we've kind of been talking about, I could have made you do like a chart like we did with the sine and cosine. This is what we're going to end up with for a tangent graph. Okay, looks a lot different than our sine and cosine functions, right? It's still periodic. It repeats itself. But it's a lot different looking than our sine and cosine graphs. These are typically not useful for periodic things in the everyday life. So like your sine and cosine can measure waves, they can measure tides, they can measure all kinds of things that happen in the real world. I'm not going to say tangent doesn't have applications in the real world, because I'm sure there's some things some smart people use it for, but it is not going to be ocean tides and like what we typically think, moon phases and things like that. Okay, so there are some important features of this graph. Notice they have this set up. A tangent B theta plus C plus D. It looks just like our other graphs, except for we're using tangent instead of sine or cosine. A is just our vertical dilation, right? We don't call it amplitude on this because it's going to stretch, like our sine and cosine graphs have a maximum and a minimum, right? So you can talk about an amplitude there. Tangent graphs don't have maximum and minimum values because they go on forever up to infinity. So it's going to stretch it out and make it taller and skinnier, or squish it down and make it shorter or fatter, but it is not going to be called amplitude for this. Notice the period here. What is different from the sine and cosine graphs? On the graph it's different, but just for period alone, we used to do 2 pi divided by b, right? The standard period of tangent, if it has not been shifted, is just pi. Because where you're doing sine over cosine, the values repeat more often. The values in the first quadrant are the same as the values in the third quadrant. So notice right here, whenever we're thinking about where our asymptotes are, this right here is 1 period. Well, that is from negative pi over 2 to positive pi over 2, right? If I subtract those, if I do pi over 2 minus negative pi over 2, it becomes like adding, and I will get 2 pi over 2, which just equals pi. So the big difference, this is going to be a big difference, is that the period of y equals tangent x is just pi. It's not 2 pi for that. So whenever you're finding the period, oh gosh, it won't let me write whenever he uses the tables. The period, instead of doing 2 pi over b, we've got to do pi over b for that. Phase shifts work exactly the same as they did with sine and cosine. And the D on the end is going to be a vertical translation, but we don't call it a midline. I don't think, anyway. He doesn't call it a midline. Anyway, I still sometimes call it a midline because if you look at, your graph is going to change from like concave down to concave up. It's like you have points of inflection at all those points. If you were to draw a line through all of those points of inflection, it is technically not a midline. But we can kind of think of it like the midline, right? Your points of inflection will be on that x-axis if it's not been moved up or down, but when we move it up or down, those points of inflection are going to move with it. Okay, so the big difference is right here. Is right there, even though it won't let me highlight it like I want to, is that it's pi instead of 2 pi for our period. So we're going to have a few different types of equations that we're going to have to do. And I am going to pull up the key for this one too because I'm a little shaky on the A part right here, and I want to make sure I don't teach you wrong on this. Alright, so, because I usually skipped a lot of this right here whenever I was teaching it before. We just did some basic things with tangent. We didn't do a few of the things we're supposed to do here. So, a portion of the graph is shown. It tells us f of x equals a tangent bx plus d. So this one does not have a phase shift. And we're supposed to find A, B, and D. So the first thing I would do on these problems is I would look for my points of inflection. They're a little harder to find than like maximum or minimum points. But points of inflection are where you shift from concave down to concave up, which looks like it probably happens about here, here, and here. Right. And if you connect all of those, that is your midline, that is your D. right? What is it for this problem? What does D equal for this problem? D equals 0. This one does not have a vertical shift. It's not moved up or down. So I think that is usually the easiest one to find. The next thing that I need to do is find the period of the graph and use that to find B. So the period of the graph is going to be from an asymptote to the next asymptote, right? You could use the middle two. I'm looking at pi over 4 to 3 pi over 4. If I subtract those, if I do 3 pi over 4 minus pi over 4, that's like a 1 pi over 4. So 3 pi minus 1 pi is 2 pi over 4, which reduces to pi over 2. Now this is our period of our function. That's how far you go before it starts to repeat itself. Is that going to be our B value? It is not. Just like with sine and cosine, it does not equal your B value, right? The period is the only one that doesn't just get plugged into the equation. And yeah, so what we're going to do here, where before we did 2 pi over B equals the period, if it is a tangent function, we're going to do pi divided by B equals the period. In this one, you don't even really have to solve. What does B have to equal? B's got to equal 2 in order for you to get pi over 2 in this case. But you can cross multiply and you'll get the same thing. Okay, so we've got B. It's very similar the way we find it as we did with sine and cosine, but it's a little bit different because we use pi. D is very similar. A is going to be a lot harder because amplitude was really easy to find from a graph with sine and cosine. We just need midline up to the highest point, right? You guys did great with that. Most everybody got that right. It's harder to do on these problems because it's not an amplitude, right? We can't really see it on the graph. So here is what we're going to have to do. And the reason I say it for last. So we've got f of x equals, I don't know what a is, but I've got tangent of b is 2. So I got 2x. And then d is 0. So I'm not even going to put that in there, but you could if you want. So I'm going to plug in the pieces that I already know. And then I need to find me a point on the graph that I know. This is not the easiest. But the best thing to do is to try to maybe look where tangent is going to equal 1. So tangent equals 1. I would use this point, although you could use this point or this point right here as well. But let's use this one right here. So at that point, our y-coordinate would be 1. What would the x-coordinate of that point be? It's going to be pi over 8 because it should hopefully be halfway between. I don't think they're going to give you anything where it's not unless it's marked because it's going to be really hard to figure out what it is if it's not marked. So, so that would be at pi over 8. So to find A, what I'm going to do is I'm going to plug in these coordinates right here. So the 1 goes in over here for the y-coordinate. A does not get plugged in for because that's what we're solving for. And I'll have tangent of 2 times pi over 8. And it initially looks like it's a problem because pi over 8 is not on the unit circle. And we can't figure that out without a calculator. But when I do 2 times pi over 8, I put 2 over 1, that is 2 pi over 8. And that reduces to pi over 4. So 1 is going to equal a tangent of pi over 4. And so for tangent pi over 4, we got to think about the unit circle. Pi over 4 is right here. Our coordinates are square root of 2 over 2 and square root of 2 over 2. What is tangent at that point? 1, because it's going to be square root of 2 over 2 divided by square root of 2 over 2. So I'm getting 1 equals a times 1. So A just equals 1 for this problem. Questions here? So I would find everything else first, and then you're going to find another point on the graph and use it to work backwards to find A for that. Okay, this is about the only thing I used to ask my kids back before I actually had to make sure I was really teaching everything because we have an exam. If I want to find the period of the function that's given here, first of all, what number do I even need to look at? The 2 right here. This is all that's going to matter for the period, right? The 4 and the 5 change the vertical expansion and not the midline, but that line that goes through the middle there. So this is the only one I need to look at. Normally, with period, I would do 2 pi divided by that number. But for tangent, what do I have to do? Not multiply. I'm just going to do pi divided by that number. So I'll get pi divided by 2. That will be my period for that. If that was a sine or a cosine graph, we'd have 2 pi over 2. But for tangent, the only difference is use pi instead. That I'm definitely going to ask you because that was a big one I focused on even when I didn't have to do as much with tangent. Okay, so let's look at example 3. And I definitely used to skip I've done these before. I used to make kids do these like when I very first started teaching pre-cal because it was in our textbook, when I had a textbook, and it was always so hard. So then I just haven't been doing it since we haven't had a test. But it's good for us to do this here. So let's look at it. Let g be the function defined by 2 tangent x over 3 minus 1. Which of the following gives the vertical asymptotes to the graph of g? Okay, so I'm going to start off thinking just about the unit circle on this. So let's just think about the unit circle. Okay, on that unit circle, right here, you've got 0, and its coordinates are 1, 0. Right here, you got pi over 4. Those coordinates are square root of 2 over 2, square root of 2 over 2. Right here, you got pi over 2. Those coordinates are 0, 1. Right here, you got 3 pi over 4. That is negative square root of 2 over 2 and square root of 2 over 2. And over here, you've got just pi, and those coordinates are negative 1, 0. Right, and that's a full period for tangent. Right? So this would be the full period for tangent if you have not done anything to it, right? And because it starts to repeat here. So if I kind of mark this right here, I highlight this. Scroll up a little bit. So see, this right here, vertical line, right, is where we have an undefined slope. So, right, oh, let's not do that. Use a different color in the pen. So right here, whenever I have that vertical line, that is my undefined slope, which means I'll have a vertical asymptote on the graph. All right, and let me mark this as well. This right here is 1 full period of tangent, right? So at pi, we're at 1 full period. But this is just for regular tangent, right? So regular tangent is going to have a vertical asymptote at pi over 2. This graph has a number in here with my x, so the period has been changed. Now, it's going to be helpful here not to think of this as x over 3, but rather 1/3 times x, like that. So if I want to know the period of this function, what would I do? What's the period we start with for tangent? Pi. And then we divide by the b value, which is that 1/3. There. And dividing fractions is easy as pi. Flip the second and multiply. So you got pi times 3 over 1. That's just going to give you 3 pi. So what that's telling me here, if I think about taking that unit circle right there, it is telling me that this is not pi anymore. It's 3 pi, right? Because that's a full period. So my vertical asymptote, which is what it's asking about, would be right here. And it's not going to be pi over 2 anymore, right? What is it going to be? It's going to be 3 pi over 2. And that's where I'm going to have a vertical asymptote. So that first vertical asymptote is going to be at 3 pi over 2. So this one right here is feeling the most promising, right? Because these others are going to be starting somewhere else, right? So C is going to end up being our answer. Let me make double sure right here. Surely that's right. Yeah, okay. Make sure I don't miss something. Then notice this has this weird thing over here with it. Because with trig functions, this just keeps repeating itself over and over and over again. So it doesn't just have one vertical asymptote. It has vertical asymptotes all the way down, right? So the period of this graph is 3 pi. So if I add a full period to the value that I have, I'm going to be at another vertical asymptote. So the way they show this is they put this 3 pi right here, which is your period, times k, which is a constant. And actually, this is not right. He needs to change this. That should not say constant, because constant can be a decimal. And we don't want to go like a portion of a period. It's got to be a full revolution. So this right here really, really, really should say all of those right there. Should not just say constant, because constant doesn't have to be a whole number. It should say integer. So k is an integer for that. But Mr. Passwater lets us use all his stuff, so we are not going to complain. But I feel 99% sure that should say integer instead of constant right there. So when you see it set up like this, that part right there next to the k should be the period of the graph, because it's just showing you it repeats every so often there. Does that make sense? Okay, let's look at this next one. A portion of the function k is shown above. Which of the following could be the expression for k? The first thing I like to look for is the points of inflection. So where you're shifting from concave down to concave up. It should always happen halfway between your asymptotes, right? So we're looking at those points right there, and if we connect them, that is our vertical shift. So there are 2 of these I can throw out right now. Which ones are they? B and D both have vertical shifts of +2, so those are not it. Okay? What is the period for this graph? How far is it from asymptote to asymptote? 2 pi. So the period for this is 2 pi. But remember, we don't just take that number and plug it in, right? For tangent, we're going to do pi divided by b equals whatever the period is. So that's 2 pi. So I could multiply both sides by b here. Pi would equal 2 pi times b. I would divide by by 2 pi on both sides. And that pi on top has a 1 in front of it, so the pi's cancel, and we get 1/2 for our b right there. So I don't see one with a 1/2. Which one's equivalent to having the 1/2? It's a right there, because if we did 1/2 times x, that x is like over 1, and we could write it as x over 2. So a is equivalent to having 1/2 times x. Okay, questions there? All right, so these last ones, we've already done some of these for that. So this is going to use your unit circle. You can just use your unit circle if you want, really, it's fine. I'm not even going to do all of these because we've already done it some. Like, for example, if I think about my unit circle here, pi over 6 is right here, and my coordinates right here should be square root of 3 over 2, 1/2. So if I want to find tangent of pi over 6, I've got to do sine over cosine, which is y over x, right? So I will have 1/2 divided by square root of 3 over 2. You cannot leave it like this. They must be simplified. Dividing fractions is easy as pie. Flip the second and multiply. The 2's can cancel. You will get 1 over the square root of 3, but even that they may not like. They're probably going to rationalize the denominator on that. So if you multiply the numerator and denominator by the square root of 3, right there, you will get square root of 3 over 3, and that's what we'll have for our answer. Let's do 4 pi over 3. I'm just going to skip around a little here. We're not going to do all of these. You'll get some on your work as well. So 4 pi over 3 is right here. No, 4 pi over 3 is not right there. That's 2 pi over 3, isn't it? Yeah. Oh gosh, still wrong spot. There's 4 pi over 3. And negative 1/2, negative root 3 over 2. So for this one, you're doing sine, which is negative square root of 3 over 2, divided by cosine, which is negative 1/2. And dividing fractions is easy as pie. Flip the second and multiply. Negative square root of 3 over 2 times negative 2 over 1. Here our 2's are going to cancel. We will get negative square root of 3 over 1. That 1 is unnecessary. Negative square root of 3 will be our answer there. Oh, sorry. Yes. Because negative divided by negative gives you a positive there. It's positive. Sorry. Silly me. Marked out the negative with that 2, but it doesn't really go with that 2. Something like tangent of 3 pi over 2. I can answer that one right away. I know 3 pi over 2 is right here, even without thinking about it. The terminal ray is vertical right there. What's the slope of a vertical line? Undefined. So I could answer it right away, or you can use the points that are there, which are 0, negative 1, and you would be doing negative 1 divided by 0, which is undefined.
Same thing for I and by.
Right, this one, undefined. Which ones would be 0? Do I have any that are 0 on here? There's one. The pi. Pi would be 0 because your slope would be 0 on the horizontals there. So, and the others are just more of the same. I'm not going to spend time doing that. I'll let you work on your assignment for this. So we had already done this. This is just throwing this back in here, make sure we're good with it. Any questions? All right.